Bienvenidos a la sesión de la tarde del primer simposio anual de Título 5. Es para mí un honor presentarles al colega Bart Reagan. Bart es el director asociado para integración del conocimiento, la investigación y la tecnología en la Biblioteca Claude Moore de Ciencias de la Salud de la Universidad de Virginia. Es miembro activo y líder de importantes grupos y organizaciones profesionales, incluyendo MLA, la Asociación de Bibliotecas Médicas. En estas funciones, él es responsable de identificar, seleccionar, evaluar e implementar. ¿Se escucha? En la grabación. Lo rompo. ¿Qué le hice?
Hola.
Es responsable de identificar, seleccionar, evaluar e implementar nuevas tecnologías de información. Reagan sostiene que el valor de la biblioteca se define mediante la preservación y el acceso al conocimiento. Interpreta la gestión de la información como una oportunidad que tenemos los bibliotecarios para hacer la transición de nuestras destrezas hacia nuevos servicios dirigidos a apoyar la ciencia. Bart recibió una maestría en Bibliotecología y Ciencias de la Información de la Universidad de Carolina del Sur. Cuenta además con una certificación en liderazgo del NLM ASL Leadership Program. Y recientemente fue galardonado con el premio Estelle Broadman Award for Academic Medical Librarian of the Year. Así que recibamos con un aplauso al colega Bart Reagan.
I'll take your mic. So bad news, I don't have any props whatsoever. I didn't realize I was supposed to bring a guitar or a hat or something. The use of the iPad is just to let me know how much I've talked, because otherwise I'll keep going. I'm here today to talk about data and the data dilemma. We've also heard this referred to as, go to this side of the stage, the data tsunami or the data deluge. One of the things we're trying to do in our library is really kind of figure out what does this mean for libraries? How do we follow our researchers into this sort of unknown world? I mean, you heard Bill talk about earlier the future and how things are changing. We believe that things are changing. We're just trying to figure out how does our profession sort of fit into that. Before I begin, a little bit about me. I have this really nasty title, which is Associate Director for Knowledge Integration, Research, and Technology. The knowledge integration is actually interesting considering what Bill was saying about having knowledge managers out there, and that's the reason that that title's in there. For the librarians here in the audience, basically what that means is our subject librarians. So it's our librarians that interact with the curriculum, School of Nursing, School of Medicine, Public Health, so forth. Research, we've always had a research liaison, sort of somebody that connects with researchers and stays connected with that group. But recognizing that there's a change going on in science right now, we've reorganized how we structured our library and our staff, and we actually created a group we call it RDOS, which is Research and Data Services. So we're trying to figure out what does this all mean. And the technology is what probably most people in the medical library world know me as, because I sort of started through web application development as well as we do staff computing and public computing and so forth. Next. So big data is all around us. It's been around us since before the internet, but one thing about big data to sort of understand is that we're putting ourselves out there all the time. You're going to put me on YouTube, right? Right? It's big data, right? It's Bart Reagan, right? Metadata. But if you think about Facebook, I would imagine that most people have Facebook accounts in this room. Most people probably go to Google, and you don't pay anything for this, right? No money exchanges hands. But your data is being used. People are mining that data. Facebook and Google are then turning this back around and to marketers so that they understand what user habits are. And I don't know if you're I was very happy when I checked Google and I found out that I was a young adolescent male, age 18 to 24. It's like too many video games or something in my life. But my wife actually found an article recently about Target and data mining and what Target's doing. And she read in the article that Target can actually predict a woman's due date when she's pregnant before the woman gets the due date from her doctor, based on her shopping habits. And so all this is done because they have a massive amount of data coming in, good data, bad data, but if you get enough data, you can begin to filter out sort of the outlying results. The other thing to sort of consider when you look at companies like Walmart, Walmart does 2.5 million transactions every single day. And so you can imagine what they can grab and extrapolate from that type of information about what people are doing, different parts of the country, different parts of the world, and so forth. So, data. And we're beginning to see some interesting things that sort of occur out of this. And so back, actually, I don't know the year, it's maybe about 4 years ago, there was a Harvard astronomy professor that was at NIH, and she was presenting on a problem that she had. And her problem was that they had scanned this sort of region of the stars and the universe and stuff, and that all the software that they had was two-dimensional. And what she really needed to do was to look around the problem and to see it in a three-dimensional capacity. And there just so happened to be a radiologist in the room. And the radiologist recognized almost immediately that they had software that did exactly what she wanted it to do, because they need to see inside the human body and look at it in a three-dimensional sort of context. And actually at Harvard, they formed a unit called astronomical medicine. And you would never begin to put those two sort of disciplines together, but the world that we're living in means, you know, this access that we have online, the amount of data that's out there. You're going to see, you know, the changes that Bill was talking about earlier. You're going to see people doing more and more interesting things in interesting ways because they can, and they know about each other. So this maybe is a little less relevant with mainly librarians in the room, but I am a librarian, so I tend to look at things from a library perspective. I'm a health sciences librarian, so when I talk about things today, I'm thinking about things in terms of how we do things in health sciences libraries. And I'm sure y'all understand more than most that a health sciences library is much different than an academic library setting. In an academic library setting, I have colleagues at UVA that we work very closely with. They have humanities and other issues that they have to deal with. When I begin to look at data and what's going on, you know, you have clinical informatics, biomedical informatics, you have HIPAA regulations, you have all kinds of privacy concerns, and so we have a unique set of problems. We have networking issues because you have the secure network and the non-secure network and so forth. Now, the other thing to understand is that I am not this kind of librarian. I will never shush you. I really don't care about quiet space. In our library, the students actually do a pretty darn good job of making sure that everybody else stays quiet. They govern their own territory. They actually define the space in ways that we didn't define it, and that's fine. I'd rather the user sort of figure out ways to use it. So I'm not that kind of librarian. I'm this kind of librarian. So I'm the guy that goes to the high-performance computing group meeting every month and listens to the really big heads talk about what they're going to do about high-performance computing, what they're going to do about data, how they're going to transmit it, how they're going to work around the issues, what are the problems, what's the money that needs to be involved, and so forth. And I guarantee you I am the least intelligent person in that room, but it doesn't really matter because I begin to hear and gain context about things that the university needs to address in a way that I would never get if I didn't put myself in that room. Excuse me. The other thing, sort of, other areas that I stay connected with are collaboration tools. So, you know, I think libraries are actually really good at this. We were very early on, you know, the internet, on social networking. I taught a class, an online class, to 700 medical librarians back in 2008 about social networking. And we had 700 people throughout the the United States because people were really interested in it, and they were interested in providing services back to their patrons and being sort of ahead of the game. And the last area is this area called data management, and this is what I've become really sort of aware of in the last probably 1.5 to 2 years, because data management is a huge issue, and how data flows is a huge issue. And I think libraries, for me, this becomes a natural transition from the things that we used to do to taking those skill sets and transitioning them into things that we can do in the future and in ways that we can be involved in the research process. So basically, I believe in general that libraries are both revolutionary and evolutionary concepts. And this always sounds a little odd because, you know, to somebody that doesn't work in a library, if you say that you work in a library, immediately they go to this sort of very traditional picture of somebody that is stamping books and shushing and worried about quiet spaces and getting their books back. But I think libraries have always been revolutionary concepts. If you think about libraries way back in the day, we were the first people to provide public access to books. It's the first time. If you weren't rich before that, you couldn't have done it. And so libraries are revolutionary concepts. When back in the 20s and 30s, when the automobile was coming about, we created bookmobiles. So you can't make it to us, we'll take the books to you, and by the way, we'll come back and we'll pick them up. Back in the 90s, we were the first to jump on creating these large, elaborate lists of e-journals and e-books, and so we're watching the paradigm as it shifts for publishers, you know, and now we're beginning to transition in other ways. So I think we're revolutionary and evolutionary, and I think we'll continue to sort of grow. Now, a lot of what I'm talking about today is sort of comes under this focus called e-science, and I don't really like the term e-science because e-science is kind of like Web 2.0. I mean, the last time that you actually probably heard the term Web 2.0 was probably 4 or 5 years ago or 3 or 4 years ago. It's because Web 2.0 was just how the web was evolving. The technology changed, you could do different things, so you did different things. So e-science to me is just how science is evolving over time. It's just how, you know, how things are changing. So, but one of the definitions that I like a lot comes from Tony Hay, and Tony Hay is the Vice President of Research for Microsoft. And you better believe that Microsoft's very interested in research and providing services to these people. And Tony says that it's a set of tools and technologies required to support collaborative network science. And in my head, what I think about what we do and how we're trying to transition is we're trying to figure out how do we meet the need of collaborative network science? How do we get to that point where we're helping somebody that maybe isn't physically in the lab anymore? Or how do we connect that lab with another lab that's not on their hall? Because what we hear from researchers is they connect through serendipity and at conferences and networking like that, but a lot of times it just sort of happens. And so how do we do that online? How do we do that in a virtual sort of space? And the last part of that, that definition says that the entire infrastructure is intended to empower scientists to do things faster, better, and in different ways. And the different ways is it's fun to watch. You know, we are like in the Wild West of technology at this point. You know, if you look back at the internet, it came up, you had email, and everybody's conversing and so forth. And then all of a sudden, social networking hit. And then, you know, everybody has broadband at home. Now everybody has a smartphone just about. All those numbers are growing. And we're beginning to see how science and everything is changing in different ways. And so if you look at something like Wolfram Alpha up there, Google goes out and it has spiders, and they collect information about websites and people's usage of those websites, and then they present answers back to the user based on relevancy. What Wolfram Alpha is it's called a computational knowledge engine. But instead of just searching random bits of data that's out there and trying to filter out the bad data, it's searching data sets. So when you ask Wolfram Alpha a question, it brings you back empirical information based on what you search for. Another sort of interesting project is this Polymath blog started by a United Kingdom mathematician. He had a math problem that had never been solved. And so he just put it out there on a blog. And he said, come on, help me solve it. And within 7 weeks, they had solved a math problem that had never been solved before. And it was solved by like 40 some odd different people that had a variety of backgrounds. They weren't all scholars. They weren't all academics. But they all contributed what they had in the shared knowledge. This becomes the wisdom of crowds. And they solved it, and they keep going. They have many, many projects now where they are just trying to sort of muddle through the issue in a collaborative network way. The Open Science Project is sort of scientists trying to address the needs that scientists have. So if you go back to the astronomical medicine unit, there was a piece of software that needed to exist for this person to do what they had to do, and it didn't exist. Well, Open Science are scientists that come together creating software that meets their needs, specifically their needs, so they're not having to hack some piece of software to get it to work. And we see this in informatics all the time. I'm always amazed at the people that are involved in informatics because those guys are smart. I mean, I should really never be allowed to talk to them because they're way smarter than I am. But, I talk to these scientists that do these like complex gene array analysis things, and then I talk to them and it's like, well, I had to teach myself how to program Python. And then, oh yeah, I have these tools, and so they have these code bases that they leverage and they all put out there, and they're all collaborating to sort of help each other do the jobs that they have to do. My experiment is a site where you can put a scientific process up, and then it can be critiqued or used or downloaded by another person. You can do this in a collaborative way. You can just put your thing out there and have somebody look at it and so forth. And the other one is ResearchGate, which is sort of like Facebook for researchers. So this is free. I don't know, you know about ResearchGate? So you go in and you put your information. It goes out to PubMed, tries to figure out who you are. It says, are these your articles, and so forth. And so it's really, to me, it doesn't have a lot of relevance to me as a librarian, but you can see how this stuff is sort of taking baby steps, along the way, and it's going to get better and better. And as we look at that sort of 2020 deadline, that year, how are things going to be different? I mean, they're going to be radically different than they are right now. And the great thing about librarianship, this is what I love about librarianship, is we get to sort of be a part of a lot of different elements of this. I don't have to focus on one area. I can help the informatics guy, but I can also work in the curriculum as well. So the other thing I just want to briefly mention is this concept of altmetrics. What data is out there? What are you going to do with this data that data was never really intended to be used for? I don't know. One of the good examples is looking like Twitter data and trying to discover like the sickest city in the United States or the country. They can. No, I'm serious. They have tools out there, and they go out and they mine the information. There used to be a site called Sick City. It's not up anymore, but. They've actually proven that they can predict like the flu outbreaks in the continental United States quicker than the CDC. It takes the CDC about 2 weeks. It takes mining this sort of data a matter of a day or two. Now, the reason we have Zotero and Mendeley up here, these are both bibliographic management tools, much like EndNote or Reference Manager, but more sort of the 2.0 version of these things. But Mendeley is a tool specifically meant for scientists. So you can archive, you can do the traditional things, but you can also deposit sort of your articles in there, and they have over 40 million articles. It's more data than PubMed. So at what point does people's ability to begin to put information out there supersede the infrastructure that already exists for that stuff to go? So you begin to be able to see how things are just changing. But like I said, it's Wild West, trying to figure out which one of these things to sort of latch onto is, I think, a little difficult at times. There are some efforts out there, and again, this is, I think, you see a lot of people trying to figure out how do we help this progress. And so DataStar is it's a data repository, but it's a staging data repository at Cornell University. And so Cornell and the library system have decided that we're going to give you a place to work on your data at the time that you need it, so you can collaborate with it together, which is a big deal because lots of people have really large amounts of data, and trying to figure out how to put that over the network is a hard process. DataCite, they don't want your data. They want to help people figure out how to describe their data, because you can have a data set and you can put it online and it means nothing to anyone because it's just this thing that doesn't have any kind of context whatsoever. And so DataCite's trying to figure out, well, what are the standards? What's the metadata standards that we need to have in place that make this thing discoverable to other people? Because the intent of sharing your data these days is so that other people can do things with it that you never intended, or that people can come in and actually verify your results. There's been an issue in the last year or two, a couple of years, with the number of retractions that are coming out of scholarly publications. And so, there are people out there advocating that the data needs to be out there. You can't just give the synthesized results in a journal article and expect everybody to accept the findings. Data One is an actual repository, and this is sort of a challenging part for librarians because it's kind of like if you're working with a researcher, you have to know the landscape to know what's going to be relevant to that researcher. And so Data One is like ecological data, but it's an actual repository. So if I'm an ecologist, I can actually put my data in this place, and they have a mechanism to help you describe your data that makes it discoverable. If I'm from another discipline, that may or may not be the case. So, and then this Dryad over here, Dryad I think has a really nice model. Dryad is concerned with posting data, biological data, that's associated with things that are actually published. So that you get the article here, I can download the data there, I can see the landscape. And then we see the government having things like GenBank, where you can go in and you can upload gene sequences and so forth. Where all this ends up, I'm not really sure, you know. But I think as academics and especially in the libraries world, it's my responsibility to sort of not, I don't want to tell the researcher what to do. Their field's going to figure out what they need to do. They will, you know, but I don't want to be blindsided by the fact that they now go over here. I want to be ready, you know. MJ Toohey, who's the director at University of Maryland, said something to me once, and I thought it was just the smartest thing ever. She said, skate to where the puck is going to be. And I don't know anything about hockey, but I know that that means that I need to be there when they're ready for me, and I need to sort of be aware of what's going on. Okay, so back to data. So the amount of data that we're producing now is just, it's huge. It's astronomical, we see from the satellite. So, and I just want to give you a couple examples. In the year 2000, they came out with the Sloan Digital Sky Survey, and in 2000, just think about this, this is 12 years ago, that satellite in about 3 weeks produced as much astronomical data as had ever been produced up that point, in 3 weeks. And in 2016, they're coming out with another one down in Chile, the Large Synaptic Survey. That's going to do it about every 5 days. And I would imagine by 2016, they're underestimating the amount of data they're going to be able to produce. The Human Genome Project, 2003, huge accomplishment. I'm sure we've all heard of that, you know, when that came about. Took 10 years for them to map out the human genome. You can do it in a week now. So just think about the tools that were available in 2003 versus now. Okay, so looking at data and what we can actually do, this slide is, I think, very telling to me. So, you know, 2006, the blue line here is our capacity to produce data and information. This is everything, the amount of information that's going out there. Here's our ability to store that data. And so you can really see the separation around 2008. So we're just producing, and you can argue that, and I think you probably should argue that we shouldn't keep everything. But you can also imagine that in this sort of area right here, we're losing a lot of information. When we talk to scientists, a lot of times they're running equipment that gathers a lot of different types of information, but they're only necessarily concerned with this one bit of it. So the first thing they do is they throw out most of the data because they only care about this one thing. And what we know from a historical context is that, you know, even today, we have people going back and looking at like shipping records that were, you know, in paper, and they're determining what the weather patterns were back then because nobody was recording the weather patterns. But the shipping people actually recorded that stuff. So for me, I wonder, what are we losing here, and how are universities, how are organizations, how is the world basically going to meet this need of storing the information that we're now producing that's out there? And an interesting thing, one of the things that we've been doing around UVA, because I feel like libraries say that they can do some things, and I feel like in other ways, like there's really no need because the researchers just do it for themselves. So, you know, we tell them we can find them a grant, you know, grant information, but they really know where their granting institutions or organizations are. But so one of the things we've been doing is we've been going around, we've been interviewing researchers in a variety of disciplines. We've been doing it on the main side of grounds campus at UVA, and then we've been doing it on the health sciences just so that we understand the context of what these people's needs are. And we were talking to one of the computer scientists, and this guy was about to retire in like a year or two, and his whole job was to study data and how much data gets lost over a period of time. And then we started talking to him about his projects and his data, and we're like, well, where do you archive your stuff? And he pointed to underneath his desk, and there was a box of hard drives underneath his desk, not accessible to anybody but him, and not organized in any particular way other than this is the hard drive I used when I worked on this project. So you can imagine there's probably not a lot of documentation about the hard drive, the software that was used, how it was organized. He probably, in his lab, knew it at the time, or maybe they had documentation at the time, but there was certainly no kept archival data on that. And the hard part is, when you're looking at what's being produced by universities and so forth, it's easy to say, well, we need more server rooms, and we need more rack space, and we need better networks and so forth. And I like this picture because it's really pretty, and it's like, wow, yeah, we can do this. It's not, but it's expensive. It's really, really expensive. And who pays for this? And what's the cost model? In this environment that we work in today, there's less money for this type of thing. Can you push that to the lab? Can you push it to the grant? Does the university need to take up the mantle and just provide the infrastructure for the researchers, and so forth? So there was a report that came out through the AAMC GIR, and the GIR is basically interested in sort of technology issues around the American Association of Medical Colleges. I didn't want to share the results because I had the results, but I'm not sure if they're going to publish them or not. But for me, the most fascinating part of reading through that survey information, so they surveyed all the institutions as part of the AAMC, about how universities and institutions are really addressing these issues. And so when they asked them, how many gigabytes do you provide people for free, your faculty? And it could have been 1 gigabyte, and it could have been 3 terabytes. And just all over the map in terms of what they were doing. And then they asked them about storing, the charges for storing. And it was a very similar thing. A terabyte might cost me $100 a year at one place. It might cost me $900 a month at another place. And so there is no sort of good model. As I look at this and I think, well, geez, how do libraries figure out what libraries need to do? And then I see this and I really understand that institutions are grappling with this issue and they're trying to figure out how do we do this in an effective way, a cost-effective way? The retention policy was also very interesting. Everybody referencing things from like, oh, there's a university policy. I think somebody said, hey, that's a good idea. And to tell you a story about UVA, about a year, 2 years ago, there was a question about one of the scholarly publications that they had, and they had to go back and they were like, well, let's go look at the data. And the data was nowhere to be found because the person that was working on the project and the data had moved on a long time ago. They had been gone for like 2 years. And then they were like, well, wait a second. The School of Medicine has a 5-year data retention policy, right? Yes. And then they started looking deeper and they're like, well, wait a second. The university has a 5-year data retention policy. It's like, yes, but that was never communicated to people. People didn't, it's like an unfunded mandate. It's like, yes, everybody should do this. It's in the the employee faculty manual and so forth, but there's no mechanism. I think coming from a technology background, what I understand is that when people have a job to do, they will step around the obstacles that you put in front of them. And if they don't even know there's an obstacle, they're just going to run their project the way they were taught to run their project. They're going to do what they have to do to get the job done. And the last one is just how the policy is governed, and sure is like, yeah, it's in the employee handbook and so forth. Okay, so at UVA, we have a CIO that he's been there probably about 4 years, and I like to refer to him as the Pied Piper because he you have to listen to what he's saying and you have to listen to where he's going because he's never going to where he's saying, so he's kind of like come along and come along and come along. And one thing that he figured out, and I guess the president figured out a few years ago, is that I'm sure you don't have the problem here in Puerto Rico, but at UVA, everybody wants to do it their way. So they end up having like 100 different ways that this gets done. One of the examples I have is when I first came to UVA, there were probably 12 different email servers around grounds, the ones that we knew about. And so they consolidated those. But you can't tell people we're all going to force you into one system. You have to sort of incentivize it and bring them along. And so the data center, there are a lot of universities now building data centers and trying to figure out how to build the infrastructure that will meet the need of this data issue that we're talking about. And so this is not unusual in any way, but it was very interesting for me to watch how this occurred. So, going to my high performance computing group and so forth, I heard about this is coming, and all right, it got built, and then all of a sudden it was like, all right, bring us your servers. Because what they said is, you know what, we're going to build this building for you. We're going to make it really redundant. So this building has multiple network connections that come into it. They go to different parts of the backbone, the internet backbone. So if one connection goes out, you lose no speed or anything, and while they work on the problem. So the other thing, it's got all the cooling systems in place. It's got all the power redundancy. This thing can stay up it's got generators and gas and everything. So this thing can stay up for a while, so that the work that needs to be done can be done. But they're not charging for it. So you put your servers in there for free. Now, the incentive for the university is when they looked around and they saw all the little server rooms that were being cooled and had special FM 200 systems, fire suppression systems, and so forth, Halo systems, things like that. What they discovered is they're spending a lot of money on electricity and infrastructure individually as a department. And so what they decided is if we build the infrastructure, they'll come and they'll use it and they'll begin to shut down those rooms, and they'll be using less electricity, and they'll save the university money, and everything's going to be backed up and redundant. And they're exactly right. In the beginning, it was like, come on, no, please bring your stuff. And there was kind of like, well, there wasn't a lot of action. Less than a year later, they said, stop. They said, we don't have enough infrastructure. They're building a second building right now, and they're actually reconfiguring this building so they can get more servers into it. So I think my point there is that when you build something that a researcher can integrate into their process that's useful to them, they'll use it. Because somebody will use it, there'll be word of mouth. It's like, oh, you should put your stuff there, and then all of a sudden you've created a service that is above and beyond what they can do for themselves, cheaper. So Hub Zero, I just want to mention this is a project that started out of, I think it was Purdue. It would start off as Nano Hub, but part of what I want to point out about Hub Zero is this changing climate. So in this world of wikis and blogs and RSS feeds and Facebook and social networking, I think science is beginning, ResearchGate. We're trying to figure out how can things change? How can you create that collaborative network online? Because you're not necessarily always working with the person that's beside you. And so Hub Zero is a infrastructure that you can go in and create a hub around a project. You can do this on your server. I think there's other places you can lease space. You can do this in a collaborative way. But it's more than just Facebook. It's tools. It's actually letting people come into the system. Yes, you can share documents. Yes, you can connect with people. Yes, you can do other things. But you can actually use sort of scientific tools that are online, and it gives you a portal, a way to come into this, utilize the tool, capture the information, and then document it in a way that you can work in collaboration with your fellow scientists. So one of the things that I'm sort of interested in and how all this works out for universities, this is a SciVal graph. Is anybody familiar with SciVal here? Do y'all have SciVal here by any chance? No. SciVal is expensive. We don't have SciVal either. We did ask them for a sample report. So one of the things the university is doing is especially our health system, is they're changing their business model. They're trying to figure out, well, that we'll just use this. I don't know if this is true or not from this graph, but what they're discovering is that UVA is heavy in basic science research, like grants. So, but we're not as heavy in clinical grants. And there are reasons for that, because we're not in a large metropolitan area, so we don't have access to the patients to do the clinical trials and so forth. But UVA, like everybody else, wants to grow, and they want to remain relevant and sustainable and to have a good model and all that stuff. But what tools like this begin to do, and this goes back to the data mining, is SciVal is an Elsevier product where they've gone out and they've distinguished who the authors are, which is the hard part for librarians, because the librarians in the audience will know that in PubMed there is no author ID, not right now. Last announcement I heard said it was going to come out in the summer of 2011, and kind of still waiting on that one, but it'll happen. There's organizations like Orchid and stuff out there. Once that happens, we're going to be able to get a better landscape, some visualization of what's going on in our institutions. All trying to get at this thing called translational science. So out there in the world, there have been a lot of what we call CTSA organizations, this clinical translational science. What I mean by that is trying to get at how do you get from the bench to the bedside? That's what people say. So how does the bench scientist, the work at the bench scientist, actually get to the patient that is here at the hospital? And the one really nice example that I have is if I'm a cardiologist and I'm working on a heart catheter, I know who the cardiologists are. I know who I need to connect with. And that's what I think most scientists tell us is like, I know who my colleagues are, both here at my institution as well as abroad. But if I'm working on a heart catheter, it would probably be very helpful to connect and probably collaborate the material scientist who's an expert on that particular material that I'm making my heart catheter out of. So translational science, trying to actually connect people that don't necessarily connect in a normal sort of post-social networking world. And I think we'll begin to see more and more of it. Much like that Polymath blog project, your background, it matters, but it doesn't have to necessarily be the same as everybody else that you're working with. So thinking of the library world, there's a guy, Scott Brandt from Purdue. He's an associate university librarian. He also teaches. He writes a lot. He refers to the research life cycle or the publication cycle as sort of this upstream and downstream effect. And downstream is where, downstream is where I think libraries have sort of focused on in the past. This is what we do really well and have done really well for a long time. We organize information, we collect it, we describe it in a way that makes it discoverable, and if you need help with it, we're right there. We can help you along with it. But if you look at the research life cycle, there's a whole bunch of things that can be done here, here, and here. So here at the beginning in the upstream, this may be like the idea generation and then data collection, and then you have analysis, and then you synthesize the data, and then you work towards the publishing model. What I'm really interested in is, going back, is how do we fit into this cycle in ways that we haven't done in the past? How do we be creative about that? How do we sort of push ourselves as librarians, not into the research process, but to just think about things in different ways? So I'm really interested in what we really can do. And so the head of our RDAS unit, Research and Data Services, we call people all the time. And I'm trying to figure out, what are you actually doing? Because I hear people talk about things that they can do and they kind of do. And so I like to call these people and ask them, well, tell me how you really use SciVal to find collaboration. And it's really hard to find things, tangible things that we can get to. And that's sort of the question that I've been struggling with and trying to answer for several years now. Now, we do have some really good partners there at University of Virginia. They've been interested in research computing for a long time, and they've invested a lot of money, and they've been refining their sort of process. And about 2 years ago, they created this scientific data consulting group, and they sort of flipped the things that they have normally done in the past up on its head, and they just said, here's what we're going to do, and here's what we're going to focus on. And the interesting thing is, like, when you look at this, well, first I like this quote because it says, libraries have been managing information for 4,000 years, which is true. And so data to me is just another form of information. It's just another, it doesn't matter to me, it's an object. Whether it's a journal article or a book, whether it's print, whether it's online. One of the things that I love about librarianship is that we connect people with the information they need. It doesn't really matter what form they need it in. We figure that out for them. But if you look at the things here on the side, what they say that they do, what they can help you with, file formats and data types, organizing files, security, storage, backups, funding guidelines, copyright, confidentiality. A lot of these things don't sound traditionally like library services. And when I talk to Andrew, and I'm like, well, tell me about what you can do versus what you think you can do. And he's like, really their job as librarians is to network, build, and connect, and to help people bridge. Because as librarians, I think libraries are kind of like Switzerland. You know, we're neutral ground. We connect with all sorts of different people, and we know what other people are doing, and so we know how to connect people who aren't normally used to connecting outside of their specific field or discipline. So, you know, that brings us to challenges and opportunities. And I happen to think that all challenges are actually just opportunities to sort of retool and reconfigure what you do. And so looking at, I just want to give you my example. So this is me. I don't mean to imply that the library is the center of the universe as much as I would like that to be the case. It's just simply not true. In fact, it's actually the opposite. Libraries to me are like satellites, and we rotate around, you know, people, whether it's curricular needs, whether it's academic needs, whether it's research, or whether it's clinical needs. And so trying to figure out what you can do, like I've already mentioned. So I go to this meeting for high performance computing. As soon as they started talking about institutional repositories, we got involved. Now, I happen to not be a big fan of institutional repositories for article deposit, which I'll tell you about in our workshop if you're there later, which is, a lot of people don't like that statement. But the reason I was interested in institutional repositories is they started off at the bat saying we're going to help people archive their data. So again, they're providing a system that that allows people to do something that I think will be useful and required by the university for you to retain it for 5 years. But the library's involvement here is not only setting up the system, but how do we set up the system that lets a researcher deposit their data easily and describe it in a way that can be found, which we're good at. We're good at user interface design. We're good at understanding user needs or leading them to a way that would allow them to wrap the thing with the right kind of metadata that would make it discoverable. Like I said, we connect with our SIDAC group. For me, I connect with these guys over here. These are the people that are going to give me the projects in the future. So I go and have lunch and talk to the director of our clinical informatics department. I go hiking, and the bioinformatics core director is going to teach me how to make beer. I'm very excited about that. He's a young guy, but you know, it's great being able to talk to these researchers, because to me, all these things are just part of the research pie, and there's no way I ever want to do informatics. I don't want to do informatics. I don't want to do clinical informatics. But libraries have a role in that, and just, you know, at UVA, and I think a lot of institutions have this, it's hard to really discover what you have in your own institution in terms of resources, and that's why I think libraries become relevant. The last thing here is just watching policy. So we know that one of the reasons our SIDAC group had a lot of steam coming out of the gate was because the National Science Foundation said every grant proposal must have this 2-page data management plan. And they said, we've been waiting on you. And they had been. And so we're watching the NIH policy, which we see, you know, 90-some-odd% of our grants on our side of campus are NIH grants. We're waiting to see if NIH changes their policy to match NSF. And at the time that they do, we're going to be ready and willing and able to help our researchers navigate the process. The other thing about libraries that I like to point out, because again, getting away from that putting your hair up in a bun thing and shushing people, is that libraries have actually been dealing with complex data for a long time. And you don't need to know what METS is. It's just a metadata standard to wrap information. If you don't know what Vivo is a open source version of SciVal, roughly. Basically, it will let you feed it information. Once you've fed it information, you can begin to map out what's going on at a particular institution, see where the collaborations are occurring, and so forth. It's not a one-to-one with SciVal, but they do some similar things. But what I like about this slide more than anything is that you can see the data structure here and how it's feeding into the system. It's really not all that different. You know, it's structured data that's structured in a way that makes it useful. And then you build the front end on top of it. So the user never has to deal with all this stuff, but you need a librarian, you need somebody that's back there organizing the information in a way that makes sense. You know, a quick story, we have all this catalog data, and a friend of mine is a music librarian. She's now the user experience librarian at UVA, and they were working on this project where they were using this really innovative technology to sort of index this information, and they were talking to the developers, and well, actually they were talking to somebody outside. So they had a developer in the room, librarian in the room, and then somebody that did some of the cataloging as well. So there's 2 librarians, and somebody asked, well, what's your #1 need? What question do you get a lot? And they said, well, we have people that come up and this is the reference librarian, and they said, I have a duet, and I play the flute, and my friend plays the harp. I need sheet music that I can do. And the reference librarian's like, well, we can't answer that question. And the cataloger's like, we've been cataloging that forever. And so all of a sudden they discovered that our catalog user interface could not answer that question, but pulling the data out would let them mine it in a way that could instantly help our users. And so librarians, I think, just understand how to organize things in ways that make sense. So this is a Vivo sort of representation of what's going on. What I'm very curious about in Vivo is, how do I provide a discovery interface that's going to make this thing useful to somebody? How can I actually foster collaboration online? And I'll tell you quite honestly, I'm swinging into MLA. That's the question I want to answer. And I keep talking to institutions, and I'm like, this is great. Being able to see this is great, but tell me how it actually created a collaboration. And I haven't had somebody that can answer that for me yet. And one of the things that's frustrating about this product, and this is why I think libraries should be more involved, is you see like this connection with this person. If you were in the live system and you roll over it, it would tell you that there were 3 articles written by this particular person. And I called one of the developers of the open source project, and I was like, well, how do I get at those 3 articles? How do I see what they collaborated on? It wasn't a software developer, it was a user of the system at an institution. And they said, wow, that's a great idea. And I'm like, but that's what I want to get to. I need to figure out how I'm going to sell something like this to my researchers so that they can write stronger and better grants and be more competitive. So back to data management plans. This is where I think we have an easy hook in the beginning, an entry into this data process that we can help users. I don't think it'll stay there very long because I think people will figure it out, but it's something for us to help learn about. And one of the things that we've done at UVA, which I think is really smart and really good, when the NSF came out and they said, you have a data management plan requirement, there was a flood of activity for our SciDAC group, and they were helping people write their plans, they were writing critiques of it. One of the things that they did is they started working on a tool that would do this for them. And if you look at this from the outside, it's like, well, why wouldn't you bring people in the library? What I think is interesting is that why would you require that somebody come to the library if we're really trying to get people to do things quicker, better, and in faster ways, in different ways? So one of the things they did is they started working on this thing called the DMP tool, the Data Management Plan Tool. And the Data Management Plan Tool is a collaboration between UVA and the California Digital Libraries and University of Illinois, and I think Data One and some other organizations as well. And so basically what they take, the information that's given to you by NSF, and so if you look at this sort of sentence right there, it doesn't matter what it says, you can see it's not very descriptive in what it wants. I got 5 minutes. I got 5 minutes. So what I like about this, I don't know how many slides I have left. What I like about this is that you don't see library anywhere on here. You don't see librarian anywhere on there. But this is what a librarian went through, read the NSF document, and wrote it. Andrea Horn at UVA in our library, our head of our RDOS unit, wrote the exact same thing for NIH. So we're beginning to feed the NIH stuff in there. And then if you've hooked it into your university properly, if your university has done this, you will also be presented with options for additional information. And this is freely available. So let me tell you how successful this has been. This came out in November of 2011. And this data is about a month old. And since then, they've had 1,400 unique users, almost 1,100 plans by 331 institutions. So it's being used. And it's being used at a time when a researcher probably needs it, which is probably like 2 o'clock in the morning. I'm going to skip that one. OK, so this is our definition of the research life cycle. And really, I'm concerned with how we're going to transition. How do we transition? And so we've been going through trying to figure out what are the things that we can do that's relevant. And you can see over here we have the data life cycle and so forth, which is, I think, the area that we are focusing on. And so looking at some of these things, here's where I think libraries have a role. Subject-specific repositories. How do we help people connect with the specific data repositories that are out there, because a lot of the stuff is not only new for libraries, it's new for science as well. The other thing is open data. So people have heard of open access, probably familiar with it. Open access is sort of, at what point should your federally funded grant and the publication be available, or should you go through an open access journal? Is there an embargo period? We're beginning to see people that want data open, and so where do you publish your data so that it becomes freely available to everybody else? And of course, citing data, it's brand new. Think about that. We help people cite articles all the time, whether it's APA or MLA or whatever the standard is. People are going to begin to have certain needs in terms of citing the original source. DataBib is just one of the sources from librarians for librarians to help understand a bibliography of the research data repositories that are out there. And again, very traditional things that I think will transition over time. So institutional repository will help you get your article in there in the institutional repository. At the same time, let's be the ones that help people get the data management in there as well. And then the data archiving and rights management, we deal with rights management all the time, what you can access, where, and so forth. What I would say to librarians is that you got to get in the room, you got to get in the lab. What I would say to researchers is find a way to bring us in so that we can help understand your process better, and we'll begin to develop stronger and richer services based on this process. And there's actually a grant that came out last week from NLM that basically says we'll give you, I think, $25,000 a year for 2 years if you find a lab that you can partner with that has a grant. So we're not taking any money away from the researcher's grant, but giving money to sort of help facilitate that process. So the government is actually very interested in helping libraries become more integrated in this process because they recognize that that need exists. I will blow through this quickly since we're short on time, but I just want to say that big data is very patriotic. One of the ideas that I'm working on right now is a collaboration with our bioinformatics core director. He's a brand new guy. He's creating a brand new service. He's physically located in our library. What we're going to begin to do is to design a service model that lets you come to one place, whether it's virtually or in an in-house place, to begin to get informatics support. And so we've got the clinical informatics guy online. You can see here, I bought a server last Friday that's going to run informatics tools on it. We're going to figure out how to teach and educate people around this process. He'll do his informatics part. We'll bring the library services into it and so forth. And then we're going to work on this grant. And this grant came out maybe about 2 weeks ago. It has a short deadline. It's called the Big Data Grant. There's actually several of these out there. But what I like about this is it specifically mentions eScience, and it specifically mentions things that, in my head, as I look at it, are a researcher or a librarian or some sort of partnership. And so when I think about things like the automation of the discovery process through machine learning, it sounds like libraries to me. If I look at the tools and multiple view massive data, that's not me, that's the researcher. But if I look at data curation, so what do we do in libraries? We curate information. They also need to curate it, so I think that really becomes a partnership. But we have to understand what their reality is, and then they have to begin to open their minds to get beyond the point that we can all do this stuff together in faster and better ways. End-to-end systems that facilitate the development and use of workflows. Again, I don't think we're ever, unless you hire a lab scientist as a librarian, ever going to be there. It's not scalable. New approaches to development for research questions. There, I think, again, they're going to really understand what they need more than anything else. And then cross-disciplinary information fusion. And to me, this really becomes that partnership as well, because we are going to understand other entities that are out there throughout our institutions that can really be part of this. And then new approaches for data knowledge and model sharing becomes that partnership. So for librarians, I would say one thing that we need people with stronger science and technology backgrounds. The science background's not me, so I might not have a job in 10 years, but I can help us get there. And to researchers, I would say that might respond that I just want to do my research. I think what we're really looking to do here is to find ways to help researchers do more research. We're trying to help them do their jobs. They don't have to worry about some of the red tape and policy or having to go out and figure out what's available to them. We can do a lot of that for them. And so I would encourage everybody to reach and to try stuff that is a little bit beyond your ability, because if, like John was saying earlier, if you don't try to do something that's beyond your capability, you'll never do it. And you can probably do a lot more than you think you can. Thanks. Are we doing questions? Or? Yeah, we can do it in the workshop.
Pues tenemos un obsequio para nuestro invitado, conferenciante. We have a present for you.
Oh, yeah?
Thank you. Very interesting.
El taller de BART va a ser en el Salón 310, en el piso de arriba. ¿Okay? Vamos ahora a tener la presentación de la profesora Gina Linskins, así que aquellos compañeros que van a estar con nosotros los invitamos para que se queden, ¿verdad? Y compartan con nosotros la presentación de la profesora Gina Linskins. Yes.
Will that go up there or no?
Yes, I think so.